a lobe. Does that make sense? Okay. When we look at this renal pyramid coming to the point, we will say there is a minor calyx and a major calyx. In your models, if you take a peek at the base of some of these tips, okay, the base of some of the pyramids, do y'all see something that's yellow? Okay.
The sponge looking stuff?
Yellow, right here, at the base of it.
These.
Right here, at the base of the pyramid.
Yeah.
Yellow. This right here is going to be your minor and majors. They're not very well represented. Okay, you'll see them better on pictures. That is where the urine is collecting. So our urine that has gotten formed is now making its way to this big sinus looking area. Does everybody see that? The little yellow? Huh? We're not going to see that on this. We're going to see it better in pictures.
Okay.
So pictures are going to show it better. Now, as urine gets formed, that's what they're trying to show you with all the yellow. Okay? The goal is to make sure that we get it into this area of the renal pelvis so that it can leave by way of the ureter. All right? That's the goal. Now, once we get it to the ureter, it then moves to the urinary bladder. As the urinary bladder expands, all right, we're going to get the urge to urinate, called micturition, okay, which we'll get to. Now, do you happen to remember the makeup, the cellular makeup of the urinary bladder? We know it's smooth muscle, but the cells were kind of unique. It kind of took the look of both, and it was termed transitional epithelium. When the bladder was empty, the cells looked like they compressed, making it look like the squamous type, okay? Then, as the bladder expanded, made them look cubes, okay? But the term for it was the transitional epithelium, all right? So, this is how the kidney would look, cut open. This is our graphic representation, so the better picture, okay? So once again, the parts that I was trying to point out, the cortex, the medulla, the renal pyramids, getting to a point where there's a papilla. Now, this area, getting up underneath all this stuff right here, the renal sinus, because sinus means a space, okay? This is kind of giving you an idea of some of the adipose tissue. Once again, it's an organ that can build up fatty tissue, all right?
What's the difference between the medulla and the pyramids?
The pyramids are actually embedded in the medulla. Okay. Yes. Okay, so now this is what they were, this is what I said was going to be clearer in the pictures, okay? The little papilla portion, which is going to have nephrons, which get to produce the urine, the first thing that has to happen, they have to go into minor calyces. Is everybody kind of following me? Like right there at the tip of the papilla? Okay? And then do you see how this one is the major? It's the big one, which will lead to the ureter.
Where's the hilum again?
The hilum, they've got this kind of overlaying it, but do you see how they're kind of representing the blood vessels going in at this little circle point? This little dip, this little bend in would be considered the area of the hilum. Okay? So, we can see that we have lots of minor calyces. Do you see how each of the renal pyramids has a minor calyx? And they come into the major. Does everybody follow? This is going to become very important.
So the major is just really in the center part,
The major is like the big portion
where it expands out.
heading to the ureter to leave the kidney. Okay, is everybody with me at this point? Okay, because we're going to have to understand. See how they've got a bunch of the red, blue, red, blue, red, blue, 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 red, red, blue, red, blue, and so forth? My blood supply. And we have to understand how that blood supply is going to get to the kidney, make its way through the tissues so that they can get to the point of where they can reach the microscopic nephron that will contain the glomerulus. So I'm going to have to be able to recognize the blood flow in, through my tissues, around pyramids, into them, making their way to the nephron. All right? Because it is going to be at the level of that nephron with the glomerulus that's contained in it that filtration occurs. So, blood supply. When the heart beats and blood leaves by way of the aorta. The aorta, as it arches and begins to descend downward, first area it meets is the renal artery. Is everybody following me? Now, something I want you to note. The renal artery is smaller than the renal vein. Why?
Because
It's taking more in. It was trying to take out more waste like
What's- does blood pool in the kidneys? So
No.
it needs to process more out?
Sort of, Marlisha. Okay? Here's what's happening. Think about when that heart beats. We've already talked about how much the blood is under pressure in that aorta as it leaves the heart, correct? It's under tremendous pressure. What do you think has happened a whole lot to the pressure from the point where it leaves the heart, makes its way through the arch, begins to descend, and the first thing it hits is my renal arteries? What do you think has happened to a lot of that pressure? Do you think a lot of that has gone down? Very little. We are under extreme pressure for the blood making it to the kidneys. People that have chronic high blood pressure problems, all right, do you happen to know anyone that has chronic high blood pressure? Because this is definitely something you will see out in the field. What is one of the organs that is majorly affected?
Kidneys?
The kidneys. Do you happen to know a second organ of the body that's affected by high blood pressure?
I would assume the heart.
Your eyes. People who have severe high blood pressure problems, chronic high blood pressure problems, two areas of the body that are severely affected are the kidneys and their eyes. Everything else, yeah, okay? But it's very.
Is that like what can eventually lead to like glaucoma? Like from the high pressures in your eyes?
Not that. Glaucoma would be where it's a buildup of the fluid pressing against the optic nerve. It's very painful. Very painful. So here's what we have to remember. It's under tremendous pressure going into this renal artery. And then, okay, this is how we're going to get the blood flow. So the renal artery is going to make its way to a segment. Okay? Look at this cone that I just mentioned, okay, where it's this cortex, the renal portion, and the medulla, okay? That segment that goes around. Is everybody following me? Now, as that comes in and we go into segment, as we reach into the lobes, we enter a interlobar because it's in between the lobes. Interlobar is going to move us into our arcuate. As we go to arcuate, we're going to hit cortical because it's got to go into the cortex, okay? And we're going to see an afferent arteriole. At this point, blood vessels are small. We are at the glomerulus. When we get to this point, that blood supply has now made its way to the nephron. This is how they're trying to represent my nephrons. They're microscopic. And it has a blood flow under pressure to a glomerulus, where we have about 1 million or more of them. Think about that for a second. So now I've got blood flow into this microscope